ED has a set limit of points, right? You can only be scored out of like what 120 or something. Like there's a certain set limit of how many points you can get. Therefore, if a proctor wants to have like separate like rankings, right? They are always gonna pick out the nitty-gritty stuff because they need something to do it. Like when it gets closer to the end of the season, then that means that everyone will get just really good at ED in general, so that uh, everyone will like basically get a perfect test, right? But like proctors need something to take off of, which means that they will always find like the smallest things to pick and take points off. So your goal in ED should be trying to like get everything thing you can such that they can't take points off. Like you can't be complacent with like, oh, I did enough of this, because there's never going to be enough for the proctor to not take points off of you. That's my little tip.
Yes, that's kind of true. Because in the beginning, um, everyone's like doesn't really do that good, and then in the towards the end, it becomes much more competitive, and they just take off random points.
You want to
Okay.
minimize that as much as possible.
I think we'll wait like a couple more minutes just in case more people join, because there's always like a few people that join 5 minutes late. Oh yeah, for people that didn't know, this is Chris. He was on the team 2 years ago, and he's currently he's gonna go to 10th grade next year, and he was really good at Olympiad in ED. Okay, I guess we'll start. So let me share my screen. Present. Which one is this? Okay, so Howard, start recording. Howard.
I already was recording.
Oh, okay. That's fine. So, for the experiment, we're gonna see ER. So I think now we're on to conclusion, right? Hey, Chris, do you want to take conclusion or should I teach it?
Has the conclusion changed a lot since I left, or like, is it similar?
Basically, just restate hypothesis and then CER. So claim is like if you support your hypothesis or reject it. Evidence is your data. Reasoning is like why. They
Okay,
just,
sure.
yeah, they just
I
took
mean,
it and just labeled it as CER.
okay, so conclusion is just like, as Adar said, it's you restate your hypothesis. Like, you would you don't, because the hypothesis is actually pretty long if you do it like how I did it. So like you can just take like the first sentence of it and rephrase it. That's usually enough. Like, they don't care too much about restating every single part of it. You just need like your independent variable, dependent variable, and like the whole process within that. That will be like restating your hypothesis, and then your CER, your claim, of course, would be our hypothesis was supported or not supported by the data. Make sure to use the term supported, because was correct is like not scientifically correct term, um which means that they can always take points off for that. And then evidence would be you would most likely just sum up your data. If you did your data table, you can just take the means of like each independent variable level, like the mean independent variable level, and then you can just like list them, or like integrate them into a sentence such that it proves, it supports the claim that your hypothesis was supported, not supported, right? And then the reasoning would be like why the data supports your hypothesis. So like the difference would be like the evidence is literally just stating the fact that these were the averages from the condensed table of values, and then in the reasoning you would say, because this was higher than this, or whatever, right? The data was different in this way, therefore the evidence supports the claim that the hypothesis was supported. God, why did I even put these CERs in? It was so much better without them.
They want to like go to like next generation science standards or whatever.
That's so
Okay,
stupid.
Drew, to answer your question, if your hypothesis is wrong, you just say it wasn't supported, and then in your evidence, you just give your like value, your data, and then in our case, since our hypothesis was wrong, we predicted like a positive trend, and then what actually happened was like the heavier one, like the normal like paper airplane went the furthest. So then you would like cite this data and just basically say like, okay, this was our data didn't follow the trend that we said. Instead, this is what happened, and this is probably due to this scientific principle or something like that.
Yeah, it's good to have like a prediction of like why you think the experiment, if it wasn't supported, then why you think it wasn't supported in general. Like in this scenario, I can just like attribute it to like maybe um by having a heavier plane, that means that it will have more inertia to keep going, and because the surface area in general is similar to the other planes, there will be less, like there will be the same amount of drag, which means that only relevant force would be like inertia versus gravity, and apparently inertia wins in that scenario. Like, you can like maybe one or two sentences at the end of your reasoning, and then you can build off of that. You can build off of that into the further experimentation. What's that next one? Applications and
Yeah,
something.
application.
Yeah, so you can build from that into like the second section of applications. I think that's what I used to do.
Okay, everyone, like write a conclusion and then put it in the chat, and then I'll just give you feedback and stuff. Oh yeah, if you need the data, let me get the data. Okay, so this, let me just get the data here. This was the data we had, and I'll get our hypothesis as well, because some people might not have been there when we did the hypothesis. So, Okay, so for the two people that have submitted hypotheses so far, um, let me just read them and give you guys feedback. Okay, for Shrey, you have to restate your hypothesis first. So you didn't do that, so just maybe fix that, and then rather than saying the data showed the plane did something, actually state the data. And then your reasoning is, yeah, your reasoning is pretty good, but you should maybe reference the data trends more, like this was a trend of the data and stuff like that. Okay, so the two big things I would recommend for you are restating your hypothesis, and you have to include what your averages were.
Also, I don't know if you guys did this last year, but like what we did is like we literally said CER there, so they literally cannot say, "Oh, you didn't have this," because obviously we did. So you, like I don't think they care if it's like if it's purely paragraph form or not. Just have like a clearly defined CER there.
Yeah, we usually do that
That's
for
just the better approach.
analysis of CER, but I guess we can do it for conclusion as well.
You probably should do it for here.
Okay. Okay, Drew, what I would say is, um, I would say is what you're saying is kind of like contradictory to each other. You're saying that our hypothesis was supported, but then you're also saying that thick cardstock paper didn't fly that far. So that's kind of like, it's kind of contradictory to each other. You don't want to do that. You want to keep it kind of uniform and saying the same thing. So in this case, since our data said that, I don't think you would really say that our hypothesis was supported, since we predicted a clear positive trend, but rather what happened was the extremes did worse, and the middle point with the medium thickness, it did better than the extremes. So you would say something along the lines of that rather than saying our hypothesis is supported. And one thing you have to keep in note is you're not always going to have a supported hypothesis. So you have to learn how to also talk about your experiment if it was not supported. And then the averages you're showing, you should try to show all the averages together rather than like kind of incorporating them into your reasoning, because you want to have a clear claim, a clear evidence, and a clear reasoning. And another thing is you kind of combined or restated the hypothesis with the claim. You probably don't want to do that because then they can take away points for not having clear and separate hypothesis and a clear and separate claim. So what I would do is I would restate the hypothesis first, and then I would state that it wasn't supported, and then say all the data at once. And I think you didn't include one of the data, so you include all the data at once, and then you do the reasoning differently. I see you included others. I wouldn't say the evidence clearly supports our hypothesis, because our hypothesis was that there would be a positive upward trend, but really what happened was like kind of like the extremes did bad, the middle did good, and then the extremes did bad. Okay, Courtney, what I would do is restate the hypothesis first. Don't just put it in parentheses, because that shows that you're kind of putting it to the side. But restating the hypothesis is one of like the things on the checklist to go grade you want. So I would clearly restate the hypothesis, then say our data didn't support it. Yes, and rather than saying our data showed that, you want to actually say what your data was. Same thing that I said for Shrey. You want to say what your actual data was, so that actually provides like evidence rather than just saying this happened. And then your reasoning, yeah, your reasoning is pretty good. You might want to talk about, as I said for Stray earlier as well, you might want to talk about data trends as well. Everyone, please try to write a conclusion. Please try to participate. Because if you don't, you won't get better. Okay, Leanna, for yours, what I would do is restating your hypothesis is not part of your claim, so I would put that separately. And then the idea of doing the CER, that's a pretty good idea, but just take the hypothesis out of the claim. And then rather than saying instead the printer paper plane flew the furthest thing, our hypothesis was clearly not supported. Yeah, put the hypothesis before. And then you wanna have a clear claim. So rather than just saying like as Chris said, you have to have the scientifically like correct term. So basically say our hypothesis was not supported by our data. And then yeah, good, you included all the averages for the data. And then for the claim, don't just say this is because of this. Say that this was the trend and the reason for this might be. You can't just you can't just like kind of directly say it since you haven't conducted an experiment to test that. So you kind of want to say this might have been because of this. This was probably because of this. And then you probably want to include the thing that you included after. You probably want to just scrap the thing that you included first and kind of add on to the thing that you included second. The heavier plane made of cardstock paper was more effective with the air resistance. You kind of want to include that, but elaborate on it probably. And yeah, that's all I would change. There's still a lot of people here that have to submit a CER, so please try one. Okay, so what I mean is for the claim, get rid of that and then put our experiment was either supported or not supported. But I mean, our hypothesis was either supported or not supported by the experiment or the data from it. You don't want to say it was. You don't. Yeah. Okay. You usually don't want to say like um. You usually want to use the correct vocabulary, and you usually don't want to say like it was correct or incorrect or it traveled like how you said it like traveled the furthest without clearly showing that it's supported or rejected.
Well, it's also that no hypothesis can ever be like correct until like it's been tested so many times that like basically it is correct, but there will never be like 100% something that's 100% correct. Like so you can say it's supported by the data, but then if another team comes around and says that, oh, it was not supported by the same experiment, then 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 that's like the scientific process of like researching and then testing and then whatever, right? So like it's just supported, never correct.
Okay, Eric, for yours, don't you don't really need to say that our hypothesis stating that the thickness paper for the hypothesis was not supported by our data. Like I said before, you kind of want to separate them. So you want to state that our hypothesis predicted that um a positive correlation as this increased, this would also increase. You want to state that first, and then in a separate sentence, you want to state the claim, just so like the proctors when they're grading it, they have a clear distinction and they have no reason to take away points. In this case, they can argue that you kind of merged them together and you didn't have one of them or something like that, and they go take out points for like random reasons like that. So I would clearly separate them. And then for our data, you want to talk about trends here. You just want to state the data. You kind of stated that our printer paper's average was this, and then the cardstock, while the cardstock average only this, and the thin writing paper only average this. You don't want to really provide your opinion in the evidence, because that sounds like you're kind of biasing the evidence. So you just want to provide your evidence as it is without going into any trends yet. Now in the reasoning, when you get to the reasoning, that's when you would state those trends and stuff. So that's where you would state like this. You can see that the extremes only went this much, while the printer paper in the middle went this much, and then you would state like this. This goes to show that the medium paper flew the farthest, and then in this, just something that's more scientifically correct here. The figure paper isn't really affected more by gravity, as Galileo proved. All things are attracted by gravity at the same speed. So rather than that, I would include maybe evidence about air resistance almost. Since it's heavier, it's the lift that's generated through the air, through it moving through the air, is not strong enough to keep it in the air for long. So I wouldn't really include gravity, since that's not really that scientifically correct, but more so air resistance and lift and things like that. I mean, I think we have enough people. I think we need to kind of move on because we're almost out of time. But if other people have a conclusion, feel free to send it to either me, Ashik, or Howard. If you want, it's a great stuff. You can also do it, Chris, if you want. But I don't know if you'll have the time to do it. Okay, so now we'll go on to analysis. No, it's like application. So basically, in applications recommendations for further use, what you're trying to do is you're just stating how you would improve your experiment, what other experiments you could test, and how this experiment is used in the real world. Something that we learned last year from Miss Morgan is that when you want to include something about how to improve your experiment, it's good if you do something that you can change while using only the same materials rather than bringing in outside materials. What we did at competition was we did one where you bring in outside materials and one where you create a better experiment with the materials given to you. So this is where you kind of want to analyze your inconsistencies in your data and state how you would improve it and how to create a better experiment. And then you also include what other independent variables to test. So for example, like you could test like the surface area or something like that. You would include other experiments you could test to get like a better understanding of the topic. It's just to like kind of develop on this and say how you would do different things differently. And then in applications and recommendations, in real world examples, what you would do is just provide real world examples, exactly what it says. Just show how this could be used in the real world. For example, the ball experiment. It could be used in the sports industry to design better balls. So for this, you could come up with something about like playing or something like that. So everyone write applications and recommendations. Or Chris, do you have anything to add first?
Like, applications is like the most BS section. You can just literally say whatever you want on it, as long as it sounds like decent enough. Like, usually what you would do is like you would switch the a good like a new like the further experimentation would be like, oh, we should switch the independent and dependent variable around such that it's the well, like not this experiment, but sometimes you would say, oh, how will the if it's like a pendulum experiment where like it's like the mass versus like mass and like string. So you would just switch the independent variable usually to something other that you can measure that affects like the same dependent variable. That's like the most like similar thing you can do in terms of like experimentation. Otherwise, I don't think there's like easy ways of doing it. Like that's just what I usually did.
And for the format, there's not really a format for applications. As Chris said, it's kind of like weird. And I mean, there's an order that they provide in the competition like book, but just you can just say it in any order. It really doesn't matter. What I usually do is I just start with how to improve the experiment, and then go to different variables like a test, and then do real world applications. Okay, so we have like 15 minutes, so we'll just try to finish applications pretty quickly. It's applications is really not that hard. It's also not really that many points. You still want to try to get a perfect score on it. I say you would try to get a perfect score on everything, but you want to try to spend your amount of time on applications so you can spend more time on more time intensive and more important stuff like conclusions and hypotheses and variables. Okay, Drew, something else you should add is what other and how would you improve your current experiment that you have right now? Do you provided a way to test a different independent variable? I mean, test a different dependent variable. That's pretty good, but I would also include another one where you would test a different independent variable because that would give you a different experiment almost to test. By changing the dependent variable, that's kind of affecting the accuracy of your experiment, which is good since that's one of the things that you need to do. You also need a different independent variable to test a different experiment. And then something else I would add is rather than just explain like better understand the properties of aerodynamics, that's kind of like a scientific application. I would also include like other applications, like it could be used in airplanes, designs of airplanes. I mean, it's obviously not going to be used in that case, but just to show like the concepts from this are used in that.
For ways to improve the experiment, it usually should be more tied into the errors section if you still have that, right? It's like the error section, experimental errors. So basically, the improvement in experiment, which would be fixing the errors that happened that would have skewed your data in one way or another. That that will probably be the best way to deal with this section. Um, and then applications, real world applications are like whatever. Literally, just think of anything that seems viable and show like explain how the experiment will like somehow contribute into like making this product better or something.
Okay, Dhruv, yeah, your experiment that you added, the other experiment is pretty good. The only thing I would probably choose something different in this case since we kind of already tested different materials since Even though papers are different thickness, they're different materials as well. So I mean, I guess you could try that if we were to try like different stuff. Yeah, as you said, cardboard and plastic and stuff. I could see you trying that one, or maybe you could try something as I said earlier about like surface area or mass of the plane or something like that. Other than that, that experiment is pretty good. Okay, we're almost out of time, so for the if anyone can submit it in the 3 minutes before the class ends, then I'll just look at it right now and give you feedback. Maybe since we have 10 minutes between classes, I can just give you feedback then. Or if you can't finish by then submit it as homework to either me, Howard, or Asher. Okay, so I guess I'll just go over Leanna since she was the only one that submitted right now, and then the other people since just do it for homework and then submit it to me, Howard, or Archie. So for Leanna, what you do is yeah, you did the same thing last time, I think. About testing how long the plane stayed in the air, so that's pretty good. A future experiment, yeah, you could do masses and then. Yeah, masses is another one I suggested, but yeah, you can do masses. That's a pretty good one as well. And then, I would kind of include this information could be in the real world while designing planes, and I would also combine it in conjunction with what Drew wrote about the properties of aerodynamics and lift, and I would kind of combine both of them rather than include one or the other. So other than that, it's pretty good. Okay, that's all for eating today. You guys can.
Do I stop the recording now?
Yeah, yeah, stop the
Yeah,
recording.
yeah, I'd say so. Yeah.